Okay, so in this presentation, I want to show you how to work out a conversion problem using dimensional analysis. The first thing you need to do is rewrite the problem. However, you do not have to rewrite all the words in the problem. That would take forever. Instead, I'm asking that you do shorthand for the problem. So, for example, how many? You're going to write a question mark. When I look at that question mark, I know it means how many. Now, how many what? What am I talking about in the problem? I'm talking about moles. So how many moles? All right, that's shorthand for that part. Now, are equivalent to, you do not have to write all those words. Instead, you write an equal sign. How many moles are equal to what? You find the number in the problem and plug it in. How many moles are equal to 0.00201 molecules? All right, so you can't just not have a unit next to a number. So there's no real abbreviation for molecules, which is kind of a pain. Sometimes I'll abbreviate it molex, but for this, let's just get in the habit of writing out the word molecules. And is it important whether or not we have water in the problem? Does a mole of anything, is that equal to 6.022 times 10 to the 23rd molecules? Hopefully you understand that no, like it depends what substance we're working with. Water is made of molecules, but not everything is made out of molecules. How many molecules are in a mole of gold? None. Gold's made up of atoms. There are no molecules in it. So yeah, it does matter that we are working with water. So we're going to need to include that in our problem. My audio got a little bit off, so yeah, here we go. So H2O needs to be included. You need to remember to write that for every problem. It's more important when our problems get a little bit more complicated. Sometimes we'll be working with more than one substance, so always be sure to label. All right, so we've restated the problem. Now you have to multiply that by the definition of a mole. So you're going to do X in a line and multiply it by the definition of a mole. So what is the definition of a mole? One mole equals 6.022 times 10 to the 23rd representative particles. That's the definition of a mole. We have to make a decision. What's going to go on the top? What's going to go on the bottom? Will the one mole go on the top or on the bottom? How we decide is what we want to cancel out. In this problem, what do we want to cancel out? Well, it might help you to think, what do we want our answer to be in? And, well, the problem is asking for moles. So we do not want to cancel moles out. That's what we want our answer to be in. The problem gave us molecules, and we don't want that to be our answer. So we do want to cancel molecules out. Then moles is what we're looking for. Molecules is what we want to cancel out. So let's think. If we want to cancel molecules out, then the molecule needs to go on the bottom. Hold on, this font is bothering me just a little bit. So I'm gonna quickly change a few things here. For example, I just changed RPs to molecules. I did that because you all are in honors class, and you should know that RPs for H2O, that's molecule. And I also wanted to see those terms cancel out. Then you put the mole on the top, because the mole is what we're getting to. All right, so molecules cancels out, the mole goes on top. You're looking at the dimensional analysis work right here. That is what you're looking at. That's what I'm looking for. You don't have to solve the answer right now. What I want to see is that you took the number in the problem and that you multiplied it by the definition of a mole. See molecules canceling out? That's what I'm looking for. Next problem. How many atoms are in, sorry about that typo of a 2, but how many atoms, notice I'm just rewriting the problem in shorthand, are in, and then I'm pulling down the number from the problem, 0.00201 moles of what? Water. And we learned from the last problem, it does matter. That's how we know what representative particle to use. I'm just going to shrink it so that I have more room to work here. And after you type the problem, we got to multiply it by the definition of a mole. So recall what the definition of a mole is. 1 mole equals 6.022 times 10 to the 23rd representative particles. Half of that definition is going to go on the top, the other half is going to go on the bottom, and it's your choice, your decision of what to do. What do we want to cancel out in this problem? We need to cancel out moles, and whatever is next to that multiplication sign, that's what you're going to have to cancel out. So if we're trying to cancel it out, then that means which part of the definition of a mole do we need to drag to the bottom? We need it to cancel out, so we're going to drag the mole to the bottom. And that means the other half of the definition of a mole needs to go on top. That font size is bothering me again, so I'm going to just shrink it down. And almost got it. There we go. Well, representative parts. That's not good enough for an honors class. What is the representative particle of water? Let's actually show that we know it by labeling it. It's a covalent compound, and that means the representative particle is a molecule. So we're going from moles to molecules. Is that the final answer? What did the problem ask for? It asked for atoms, so we have to do another step. We have to cancel out molecules now, and we have to get to atoms. So you have to think about the relationship between a molecule and an atom. How is a water molecule defined in terms of atoms? We're going to have to multiply by the definition of a water molecule when it's defined in terms of atoms. So here that is. 1 water molecule equals 3 atoms. I'm getting that because water is H2O, and if I were to draw a picture of a water molecule, I would require 3 atoms to do so. It's the Mickey Mouse molecule. So which side, what half goes on the bottom? Well, I need to cancel out molecules. So I'm going to put what I want to cancel out on the bottom. And the other part of the definition needs to then go on the top. And in the case of water, it's 3 atoms. This is the work I'm looking for. It's 2 steps long. It's called dimensional analysis. It took 2 conversion factors in order to get to the right answer. When you get to checkpoint 8, you're going to have to solve it, but for now, we're moving on. Next question, how many ions are in 0.00201 moles of water? Water is a compound made up of covalent bonds. That means it's made up of molecules. Molecules are made up of atoms. So there are no ions in water. Ions don't represent water. Ions are not, we don't consider water to be ionic. So we are going to say a big 0. There are 0 ions. Trick question. Next question. How many ions are in 0.00201 moles calcium chloride? So let's go straight into rewriting it. Question mark ions. How many ions are in 0.00201 moles calcium chloride? I'm awesome. I remembered to put that little subscript of a 2 there because I canceled out the charge. Calcium is positive 2. That means it takes 2 chlorides to cancel it out. Now I have to multiply that by the definition of a mole. I know mole's going to have to go on bottom. I put A on top because A means 6.022 times 10 to the 23rd. And I'm trying to think of what the representative particle is for calcium chloride. It's ionic. Ionic is represented by formula units. So I now got formula units. I need ions though. So formula units are made up of ions. So in one formula unit, how many ions are there? Well, calcium has a calcium ion. We have a chloride ion. It's going to take 2 chloride ions to cancel it out. So quickly we can see there are 3 ions in every one formula unit. So this was a 2-step problem where we had to multiply by the definition of a mole, and then we had to multiply by the definition of a formula unit of calcium chloride defined by how many ions it had. So 2 conversion factors, you can see the moles cancel out. Sometimes people put a 1 under there. The formula units cancel out, and we're left with ions. Again, we're not going to solve this until about checkpoint 8, because right now all I care about is that your dimensional analysis is in good shape. And I really want you to pay close attention to making sure everything is labeled the right way. I'm sorry I couldn't be there today. I hope that this video helps you and make sure that you have the right work. I outlined people you can ask on my big campus, and I think the substitute today knows a little chemistry, or actually she might know a lot. I think she might have majored in it by what I hear. So I think you can ask her too if she's cool with that. All right, thanks so much. If you have any questions, email me or ask those people around you who usually know things. I put their names on my big campus.